Hello everyone, my name is Sunit and I made this short video to quickly understand about our poster. Revisiting heavy hitters, don't count packets, compute flow interpacket metric in the data plane. So first let's start to discuss what are heavy hitters. So there are different definition of heavy hitters, but most common definition is we select those flows as a heavy hitter which contribute most of the network traffic in fixed time interval. But why we need to detect heavy hitter? So a number of network management applications such as congestion control, quality of service management, and flow size awareness routing can benefit from the identification of heavy flows or heavy hitters. So the basic approach we follow to detect heavy hitter is counting packets per flow, and most of the existing heavy hitter algorithms using the same approach. In this poster, we are focusing on the interpacket gap as a main metric for heavy hitter detection. So the question is, we already have packet count approach, so why we are looking for other approach? So there are some major benefit which encourage us to use IPG for detecting heavy hitters. If we use IPG to decide whether the flow is heavy or not, then we don't need to reset switch memory in frequent time interval. Also, we can directly report the heavy hitter flows to the controller, and it is not required to collect all the data statistics by a controller in regular time interval. In this way, we can reduce the control channel overhead. Another major benefit of this approach is that it does not require any measuring interval. It means whenever the flow turns into heavy hitter, we can report the controller and don't need to wait till the end of time window. It means this approach consumes less detecting time. Also, using this method, we can easily detect hidden heavy hitters, which is not possible with fixed time window approach. Here is our main idea. This is an example. There are two flow tables here. One is counting packets and the table below is calculating average IPG. Whenever we find that the average IPG metric satisfy the predefined threshold, we report the flow as a heavy hitter. So here we can also notice that the low IPG value indicating heavy hitters. Here we are showing that basic difference in keeping the flow state in the data plane. So in the counter based approach, we keep flow ID. Commonly we keep the flow ID and counters, while in IPG based approach we store flow ID, weighted moving average of IPG values, and ingress timestamp of last packet of a flow. And we use the standard formula to calculate the exponential weighted moving average, which is given here. So our initial results are very promising and we use the Kaida traces for our evaluation. In the first figure, we plot the graph between weighted IPG and flow throughput. And figure shows that a strong correlation between them. And in the other graph, we use the IPG metric in the space saving algorithm instead of packet count and evaluated the performance. And the results suggested that the IPG metric are a strong candidate for the heavy hitter detection and also for the other traffic management application. IPG based design can fit with many existing counter based algorithms. For our prototype implementation on Tofino hardware switch, we use Heavy Keeper algorithm, which is easy to implement on programmable hardware. And within the constraint of today's programmable hardware, we have successfully implemented our design. Since we rely on the approximate calculation of moving average within the switch hardware, so we plot the runtime weighted IPG values in the Tofino hardware and simulator for four different flow throughput rates. Figure confirms that the Tofino hardware and simulator do not have the major difference in the weighted IPG calculation. Here we are showing our ongoing work and future plans. So current method can miss short-lived heavy hitter flows. So in our ongoing work, we are focusing to introduce flow length as another metric which we can use to resolve these issues. Also we are trying to use IPG slot or range to detect heavy hitter, where we only need 8 bits to store the weighted IPG instead of 16 bit which we are currently using. On the performance path, we are doing latency evaluation on switch hardware. And for more detail about our work and before TNA code, please visit our GitHub link or you can scan this QR code. Thank you so much.